Here we want to differentiate the function h of z, which is equal to the natural log of the square root of x squared minus z squared over a squared plus z squared. Well, the first thing that we want to do is we want to make sure that we can simplify this using the properties of logarithms. So this is equal to the natural log of a squared minus z squared over a squared plus z squared to the power of 1/2. Okay, and then we can then use the property logarithm of exponents, so it's going to be 1/2 times the natural log of a squared minus z squared over a squared plus z squared. Okay, and then we know that this is going to be h of z, which is equal to 1/2 times the logarithm. Well, this is 1/2 times the logarithm of a squared minus z squared minus the natural log of a squared plus z squared. And then if we distribute the half, we get h of z, which is equal to 1/2 times the natural log of a squared minus z squared minus 1/2 times the natural log of a squared plus z squared. So now that we have that, now we can then take the derivative of this function. So in order to find the derivative of this function, we're going to find h prime of z. So what that tells us is that for the first term, we're going to have 1/2, and that's the natural log, so that means we're going to have 1 over a squared minus z squared. And we want to multiply it by the derivative of what's inside here. Well, that derivative is going to be negative 2z because it's with respect to z, so minus 2z. And then minus 1/2 times, it's going to be 1 over a squared plus z squared. And then what is the derivative inside there according to z? That's going to be positive 2z. So now let's go ahead and then simplify this a little further. So we have h prime of z. And so in the numerator, we're going to have negative 2z times 1, which is negative 2z, over 2 times a squared minus z squared, minus, it's a minus, we have 2z in the numerator, because that's times 1, and then times, over 2 times a squared plus z squared. So here we can simplify the 2's. And so we have h prime of z, which is going to equal negative z over a squared minus z squared minus z over a squared plus z squared. So now what we're going to do is we're going to go ahead and then combine these into one term. So what we have is a common denominator of a squared minus z squared times a squared plus z squared. And again, a squared minus z squared times a squared plus z squared. So we multiply the first one by a squared plus z squared, so that's negative z times a squared plus z squared. So if we distribute that, we get negative a squared z minus z squared. Over here, we're going to multiply this by a squared minus z squared. So z times a squared minus z squared gives the following. That's a squared z minus z squared. And now we're going to have to distribute this sign and then combine like terms. So what we have is h prime of z, which is going to equal negative a squared z minus z squared minus a squared z plus z squared, all over the common denominator of a squared minus z squared times a squared plus z squared. So we can eliminate the negative z squared and the plus z squared. So if we combine like terms in the numerator, we get negative 2a squared z. And if we multiply the denominator to difference of squares, so we're going to get a to the fourth minus z to the fourth. Or if we want the numerator to be positive, which would be 2a squared z, if the denominator would then be negative, that means that z to the fourth would then be positive and a to the fourth would be negative. So it could be either or of those solutions.